So hey guys, welcome to another video, and as of this video, well, this is a video of class 9, the next chapter, polynomials. So as of the previous video, we dealt with the previous chapter, the real numbers, and we'll be moving on to the next chapter. And as you all know, we've started a new segment called Motivational Mondays, where we cover all the motivational concepts. So do follow that, and this will be a continuation of your class 9 course, and we will further be continuing for every other chapter of class 9. So let us start with polynomials. Well, let's deal with some major concepts of this chapter. So the first concept which we will be dealing with in this chapter is what is a polynomial. So what are polynomials? And then we'll be classifying it based on some certain criteria. So we'll be classifying the types of polynomials using two major criteria. The first one would be the degree of the polynomial and the number of terms. So we'll be classifying the same polynomial with two different types of categories, the degree and the number of terms. And we'll be seeing what a degree is, and the next sub-concept would be what coefficients. So what are coefficients? We'll be dealing with that as of the second sub-concept. And then the next concept would be zeros of a polynomial. Here we'll be dealing with what are the zeros of a polynomial, and like what are the numbers which represent the zero of a polynomial, and what is this concept basically. So zeros of a polynomial will be our next concept. And the third concept would be your remainder theorem, where you try to divide two polynomials and find the remainder and the quotient. So I'll write as division algorithm of polynomials. So division algorithm, where you try to divide two polynomials and find the quotient and remainder. So we'll be dealing with this division algorithm. And as of the last concept, well, this is the last, before the last concept, we'll be dealing with some how to find the zeros of the polynomial. Here we'll be dealing what are the zeros of the polynomial, and here how to find them. So this will be our fourth major concept of this chapter. And finally, the last one would be the basic formulas which will be your base to your whole 9th standard and 10th standard. So some basic formulas are included so that you can make calculations a bit easier. So we'll be dealing with formulas like the basic x plus y the whole square, x minus y the whole square, and such. So we'll be dealing with some basic formulas which will be a base to your 9th and 10th standard. So let us start with what are polynomials and how to classify them. So when we try to classify them based on the number of terms, well, if a polynomial has one term, then it is called monomial, where mono means one. So monomial. If a polynomial has two terms, then it is called a binomial. If it has three terms, then, well, you guessed it is trinomial. And four or more terms, then it is called a polynomial. So four or more terms, it is called a polynomial. So based on number of terms, it can be classified into a monomial, a binomial, a trinomial, and a polynomial. So let me give an example for each of these cases. So for the example for monomial, we can take an example of x or x square. Now x square has only one term. So x square has only one term, and well, it is a monomial because it has only one term. Now for the example of binomial, with the same x square, I am adding another term 2. So x square plus 2 is a binomial because we have two different terms. Now as of trinomial, with the same x square, I am adding another x square plus x plus 2. This is a trinomial because we have three terms in it. As of polynomial, well, four or more terms is considered a polynomial. So x cube plus 3x square plus 2x plus 1 or any such thing is considered as a polynomial. But in general, we call all these terms as polynomials under a certain basis. So this is also a polynomial, an example of polynomial. This is also an example of polynomial, and this is also an example of a polynomial. Well, why do we do this? Because if we want to name this, then we can call it monomial. Especially if we want to name this, then we can call it monomial. If we want to give a special name for this, we can call it binomial because of the two terms present in this equation. If we want to name this, then we can call this trinomial because of three terms present in this equation. But 4 or more, we don't have a specific name for it, so we are naming it polynomial. And in general, if you see any of these, then these are all called polynomials. So don't get confused if they say this is a polynomial and you wonder if it doesn't have, like, it has only 3 terms, then why are they calling it polynomial? It should be a trinomial, right? Well, all of these are commonly considered as polynomials, so that is a general term. A polynomial is a general term. So now you know how it is divided based on the number of terms. Now we can further divide the types of polynomials with respect to the degree. So degree is another classification with which you can divide the type of polynomial. So what is a degree? That is our first question. Well, I am saying that we can classify the polynomials with respect to the degree. But in turn, what is a degree? Well, degree is something like, I'll give you an example. Let us take an equation x cube plus 3x square plus 2x plus 2. This is an equation. Well, the degree of this equation, how am I going to find it? Well, it is very simple. The degree of the equation is the highest power of x. Now, what is the highest power of x in this equation? The highest power of x is 3, right? X cube plus 3x square plus 2x plus 2. The highest power is 3. Let me take another example. X square plus 5x plus 1. What is the highest power of x in this equation? Well, as you can clearly see, the highest power is 2. So, the degree of this equation is 2. Let me take another example. X power 4 plus 3x power 3 plus 1. What is the highest power in this equation? Well, it is easy. 4 is the highest power. So, the degree is 4. Now, let me give you another example. X power 4 plus x power 3 plus 3x power 5 plus 1. What is the highest power of x in this equation? Well, 5 is the highest power, and hence that is the degree. Now, we very well know what is the degree of a given equation. Now, how can we classify a polynomial with respect to its degree? Well, now we know that what is a degree? Well, a degree is the highest power of x in a given equation. Now, if a degree is 1 or 2 or 3 or 4, we can specifically divide it with respect to the number in the highest power of x. So, we call this a linear equation. A degree with 1 is called a linear equation. A degree with 2 is called a quadratic equation. A degree with 3 is called a cubic equation. A degree is 4 is called a biquadratic equation. 4. So linear, quadratic, cubic and biquadratic are the classifications under the degree. So if suppose we have a linear degree, well, what is a degree? Well, degree is the highest power of x. So suppose, let me give an example of linear polynomial. So x plus 2. Well, this is a linear polynomial because the highest power of x is 1. 1 is linear and this is a polynomial. Hence, this is called linear polynomial with degree 1. Now, let me give an example of a quadratic polynomial. Quadratic polynomial has a degree 2. So, I will give an example like this. X square plus 2x plus 1. Now, this is a polynomial with degree 2 and hence this is called a quadratic polynomial. Now, let me give an example for cubic polynomial. 3x cube plus x square minus x plus 1. This is an example of a cubic polynomial with degree 3, and with the biquadratic polynomial we can give an example like this. Well, this is also a biquadratic polynomial. Don't get confused with the number of terms over here. Number of terms is another separate classification: monomial, binomial, trinomial and polynomial. But the degrees is rather very important because we will majorly be classifying the polynomials based on only this: linear, quadratic, cubic and biquadratic. So it is not necessary if you identify it as a monomial or a binomial, but the degree is rather very important. So the degree is 3, then it is called a cubic. The degree is 4, it is biquadratic. Degree is 2, quadratic, and degree 1, linear. So that is it for the classification of the polynomials based on number of terms and the degree respectively. So the second concept which we will be considering is coefficients. So what are the coefficients? Well, I wrote some equations such as this, right? X cube plus 3x square plus 2x plus 1. This is a polynomial of degree 3, so this is a cubic polynomial. Well, if this is a cubic polynomial, then what are coefficients? Well, coefficients are the numbers which are present before this x term. There are terms such as x cube, x square, x, and x. There is nothing over here, right? So we can write x power 0. X power 0 is 1. So anything multiplied with 1 is itself, right? So we can write x power 0 over here. So anything before this there is 1 over here. So anything before this term x cube or x square or x power 0 is considered a coefficient. Let me give you an example. A common equation, let me give you a common quadratic equation. Ax square plus bx plus c is a common quadratic polynomial because the degree is 2 and it is a polynomial. Hence this is a common, very basic quadratic polynomial, and a, b and c can be any numbers. So a can be 1 or 2 or any integer or any rational number or any real number. So you dealt with real numbers for the first chapter, right? So a, this is the symbol used for belongs to. So a belongs to any real number. Similarly, b also belongs to any real number. That is the same for c. So c also belongs to any real number. So what are coefficients? Well, in this equation, a, b and c are the coefficients. Why are they the coefficients? Because they are the coefficients for this x term, x square, this x and this one, x power 0. So they are the numbers which precedes the x term. So a, b and c are the coefficients. There is another concept left behind. So what are polynomials? That was the first question for us, right? First question arising to us. So what are polynomials? So how, now if given with any polynomial, can we say that it is a polynomial? That will be the second question rising to us. So you can ask whether if I give some equation like this, x plus 2 by x, if this is this a polynomial? Or another equation like this, x square plus 3x power minus 3, is this a polynomial? And you can also ask questions like this, x power 1 by 2 plus 3x power 1 by 3 plus x square, is this a polynomial? Well, each one of these expressions is not a polynomial. Now, you can wonder why are these not considered as a polynomial? Well, there are some equations which are considered as polynomials and there are some equations which are not considered as polynomials. Well, the power of the terms x will be a whole number. So let us take an example. Suppose the power is in whole number, so x power 2 plus 3x plus 1. Well, all the powers of x, so consider this as x power 0. So all the powers of x are whole numbers. 2 is a whole number, 1 is a whole number and 0 is a whole number. So all the powers of x are whole numbers. What are not considered polynomials are the powers when the powers are not whole numbers or it is rather negative or in fractional terms. So when powers are not whole numbers, they are not considered as polynomials. Take the example of this one. Why isn't this considered as a polynomial? Well, the power, if you take the reciprocal of this, when you try to bring an x to the numerator, then it will automatically have a power of negative. So it will change the power to a negative. So x power 1, 1 by x power 1 can also be written as x power minus 1. So automatically the power becomes negative and negative numbers are not whole numbers, hence it is not a polynomial. So this is ruled out. What about this example? Well, this example is also the same because these are not whole numbers because it has a negative sign over here. So this is also ruled out. What about this? Well, this has fractions in its power and fractions are not whole numbers. Hence this is also ruled out. So only the polynomials are only the equations which have the power as whole numbers. So this is, well, it is considered as a polynomial and these are not. So that is how you classify whether equation is a polynomial or not. And as of the next concept, we will be dealing with what are zeros and how to find if a number is a zero of a polynomial or not. What are zeros now? Zeros of a polynomial are the numbers which when substituted in the polynomial gives us the result as 0. Well, it seems simple, right? The concept is also very simple. Suppose let us take an example of a polynomial, a quadratic polynomial x square plus 2x plus 1. Now, let us come to the concept of zeros. What are zeros? Zeros are the numbers when substituted in place of this x, which when gives us the answer 0 is the zeros of the polynomial. Now let me give you an example. Try substituting the value minus 1 in place of x. Well, we write it as in all the places of x you substitute minus 1. So f of minus 1 equal to minus 1 the whole square plus 2 times minus 1 plus 1. Now when you start evaluating it, minus 1 the whole square is 1, 2 times minus 1 is minus 2 plus 1. So 1 plus 1 is 2, 2 minus 2 is 0. Hence the value is 0. Now we come to know that the value minus 1 which when substituted in place of x gives us the result 0. Hence minus 1 is a 0 of this quadratic equation. Now, there can be multiple zeros for an equation. In this case, the equation is quadratic, hence it can have up to 2 zeros. Now, this is a concept which you have to remember. If according to degree, suppose if you have a equation with degree 2 which is quadratic, then it can have up to 2 zeros. Now, if an equation is equation such as x cube plus 3x square plus 2, suppose this is the equation given to you, then it can have up to 3 zeros. Now I mentioned the term up to because it can have either 1, 2 or up to 3 zeros. So, well, it can have either 1 zero or 2 zeros or 3 zeros. Now, let us move on. So, now you know what are zeros. If we try to substitute the zeros, the values, given values in place of x, and we get the result as 0, then well, it is called a zero. So, now we know the concept of zeros of a polynomial and how to find them if we are given with the values. Just simply substitute the values which are given with into the polynomial, and when the result is 0, then we obtain the 0 of the polynomial. Well, further we will be dealing with the remainder theorem and how to find the zeros of a polynomial and the concepts like algebraic identities in the next video. And as of the future videos, we will be dealing with future chapters. So see you guys.